Hey everyone, so I'm going to do a quick recap of what we covered on our last class, and then that's going to sort of segue us down into this stuff down below, where our focus is looking at how elements combine, right? How elements combine to form compounds and molecules. All right, so you don't have this page, but that's okay. I just want you to sort of follow along. And if you want to write this stuff down, you could sort of pause it and write it down and then fill it in as we go. But what I want you to keep in mind is we've introduced this concept um, of atomic structure, and our goal is to sort of understand how atoms, we want to understand about their structure, right? And then how that structure allows them to form molecules or compounds. And we'll talk about the difference between compounds and molecules because they have slightly different meanings. But the whole idea here is that we're going to learn about the biological molecules, right, that make up our cells, that exist in our bodies. And once we understand their structures, how they form, right, then we can sort of make sense of how they behave, right, what their function is. So that's the build up here, right? So I want you to keep that in mind, that the goal is we learn about atomic structure, then we can learn how atoms come together to make molecules and how those molecules are shaped and formed and how they function. All right, so quick recap here. Here's our guide to the atom. And so if we go around this starting from the inside, if you remember, this structure is the nucleus, and that nucleus is made up of these red uh, subatomic particles, which are protons, and those protons carry a +1 charge. And the nucleus is also made up of these green circles, which are neutrons, and those neutrons carry no charge, but that's our nucleus. And then these particles, subatomic particles that are kind of moving in the space around that nucleus, those are our electrons. All right. And what we didn't get to talking about on the last class is that we see these electrons kind of existing in these layers, and these layers are what are referred to as energy levels. And this sounds all pretty intense and complex, but we're going to see it's pretty straightforward. Now, if we take this whole atom, we can sort of express all of these particles in a particular way that makes it more convenient rather than drawing the whole picture of the atom. And so that's what we were talking about and finished up on last class, is looking at this. This is the isotope uh, notation for the element helium. So we can see what we've got expressed here is the letters He, which represent the chemical symbol for the element helium, and then our mass number expressed at the top. And what we want to remember is that our mass number is the number of protons plus neutrons. Down at the bottom, right, I'll just change colors here, but down at the bottom, we've got this number 2, and that represents the atomic number, which, if you remember, is the number of protons. Now, what's not shown for this isotope of helium, or over here, there's no number, and that means that there's no charge to this helium, right? But if there was a charge, we would see that charge here. And we're going to talk about that because that charge is related to the number of protons and electrons that exist. So let's look at this atom here and let's count how many protons do we have. We've got 3 red ones, 1, 2, 3. And if you were to look up, and I can flash back to give you a sort of reminder here, if you were to look on this periodic table and look for the number 3, it's this element right there. And if you can't read that, that is the element lithium. So the fact that if we look at this one, the number of protons equals 3. And if we look at the number of neutrons, 1, 2, 3, 4, there's 4 green ones. So we got a number of neutrons equals 4. And then we've got 3 electrons, right? So we've got number of electrons equals 3. What we want to keep in mind is that when we say 3 protons, remember that those are 3 positives. When we say 3 electrons, we say that those are negative, but no charge with the neutrons because they're neutral. So we could actually put together the isotope notation for this atom lithium. So I would start by writing the symbol, and then in the top left corner, I'm going to write the mass number. Now remember, the mass number is protons plus neutrons. So if I look up here, I've got 3 protons, 4 neutrons, so I have a mass number of 7, right? And then if I look at the bottom left corner, I've got the atomic number 2 for helium, but the atomic number for lithium is the number of protons, which is 3. So that number would go there. Now let's look at this charge. What would we write for a charge? If you want to pause the video and just think about it, remember the charge is going to come from the protons and the electrons because they're the only charged particles. So if you pause the video and had a thought about that, if we've got 3 positives and 3 negatives, then we have no charge, so we're not going to put anything in that spot. By leaving it blank, we indicate that it's neutral and has 0 charge. And this is true for all atoms, right? All atoms are neutral. That means that they have the number of protons equals the number of electrons. Okay? What I'm going to get you to do is pause the video, and I'm going to get you to try this, and I want you to figure out what are the number of protons, what are the number of neutrons, and in this case, we've got a charge, so I want you to try and figure out the number of electrons. Okay? Pause the video, give it a shot. Okay, so let's look at this. So if I start with the number of protons, that's the atomic number, which has to be the bottom left. So therefore, this thing has 17 protons, right? Or 17 positives. The number of neutrons, well, we can't get it directly, but we know this mass number is protons plus neutrons. So then, if we just subtract the number of protons, we will get the number of neutrons. So if we take 36 and we subtract from it 17, that's going to leave us with 19 neutrons, right? Okay, and then finally, we got to look at our number of electrons. So here we see that we have a -1 charge. Well, let's imagine that we don't have any charge for this chlorine. So if it was neutral and it had 17 positives, then it must have 17 electrons because it's neutral. But if we have a charge of -1, that must mean that we have 1 more electron than we do protons. So to give it that -1 charge, so we have 18 electrons. Okay, I'm going to write down 2 more different examples of isotope. Actually, what we could do is let's flash over to here. And if we scroll down, I'm going to get you guys to try these 3 questions right here. Give it a go. Pause the video and then restart the video to see the answers. So first question, what is the atomic number? So if we're looking at this isotope here, and if you didn't realize that's the one we were looking at, then maybe pause the video again and give it a go. But atomic number for this element over here would be the bottom left, so that's 12. So the answer would be C. How many protons does this element have? Well, the atomic number is the number of protons, so the answer is the same. And now the third question says, how many neutrons? Use your collaborate pen or finger or text the option. This is when I was doing online classes, but to figure out the number of neutrons, remember that we're going to take the mass number and we're going to subtract from it the atomic number. And in this case, the mass number is 22. So we're going to subtract from that 12, and that's going to leave us with 10. So we have 10 neutrons in this element, and that element is magnesium. Mg stands for magnesium. Now, going a little bit further, right, we've got this charge of +2. So I'm going to pause the video again and see if you can work out how many electrons this magnesium must have. All right, again, if it's magnesium and it has an atomic number of 12, well, that must mean we have 12 protons. Now, any atom of magnesium would also have 12 electrons, but this is not an atom, it's a charged ion. So because it has a charge, we refer to it as an ion. And in this case, it has a charge of +2. So that means it must have 2 more protons than it has electrons. But we can't take away or add protons because that changes what the element is. So all we can do is change the electrons. So therefore, we're going to change those electrons to be 10 electrons. So now you can see we've got 12 positives and we got 10 negatives, and that's going to give us a net charge of +2. We'll do more work with this on Monday. So if you still are kind of not sure, no stress. We're going to do a little bit more. Now, once we've got that notation down and we can sort of start to figure out, the number of protons, number of neutrons, and number of electrons, where this becomes important is ultimately what we really want to know are these electrons, and we want to know how those electrons are arranged around the atom. If we look up here, you kind of see that there's this interesting scenario here where we've got a couple of electrons in this first energy level, remember these? And then we've got one electron out here in this outer energy level. Remember we talked about this last day that the electrons are involved in making bonds, in making chemical bonds. Okay? And so by organizing the picture of an atom with the electrons, we can sort of see how different atoms will come together and make bonds with each other. So what you want to understand is, let's pretend we've got this nucleus here with these protons and neutrons. And every single atom has these energy levels that exist around the atom. And those energy levels are where we find the electrons. And the electrons, how many electrons are there and their organization depends on each unique element. What we want to understand is that these energy levels hold only a certain number of electrons. The first energy level holds 2 electrons. The second energy level holds 8 electrons. And the third holds 8 electrons. And there's more energy levels, but we'll start with just that for now. And this is true for any given atom. So let's take an example. Let's take something fairly simple to start with. Let's take the element nitrogen. Okay? So if we were to look up nitrogen on our periodic table, we would see that it has an atomic number equal to 7. So therefore it has 7 protons. Okay? And because it has 7 protons, it will have also 7 electrons. So we've got 7 protons, we have 7 electrons, and for the neutrons, we'll just leave that for now. We don't have to worry about that for showing this atomic structure. What we're going to draw here is what's called a Bohr model. This is named after a famous chemist who sort of deduced the atomic structure and the electron arrangement of electrons in an atom. So what we're going to do is we're going to put the element's symbol in the center, and that represents the nucleus. Now, N doesn't stand for nucleus here, it stands for nitrogen, right? The element nitrogen. But the symbol is going to represent where the protons and neutrons are. What we're going to do is we're going to put in these 7 electrons, keeping in mind that we can only put 2 electrons in the first, 8 in the second, and 8 in the third. So what we do is we start with putting 2 electrons in the first. and we're going to put them spaced out, kind of at the top and the bottom, or you could put them at the sides, left and right. But you want to remember, if you recall, about like charges, two negatives would repel each other, so they kind of move away from each other. Now we're going to put the remaining electrons in, but we have to go to the next level. And what we do is we start by putting them in the compass positions. So north, east, south, west, and then we start to pair them up. But we have to consider how many we put in. So far we put 2 in the first, and then 3, 4, 5, 6 into the second, but we only have 7 to put in, so we put that 7th one right here. And this is called the Bohr model. It shows us the arrangement of the electrons, and what it's going to show us is that these electrons that are all by themselves in the outer level are going to be involved with making chemical bonds. Okay, let's try another example. Let's have a look at, how about something like oxygen? All right, or let's do this chlorine. We've got chlorine up here, all right, but we're not going to do the ion, we'll just do chlorine. Okay, so chlorine has an atomic number of 17. So that means the number of electrons equals 17. Remember, this atomic number is the number of protons, positive charge, and this is the number of electrons, negative charge. So chlorine has the element symbol Cl, so that's going to represent the nucleus in the center of the atom. So we've got 17 protons, we've got 17 electrons. We can put 2 electrons in the first level, and we can put up to 8 in the second level. So we got 3, 4, remember, at the compass positions, north, east, west, south, and then we start to pair them up. Now keeping in mind we got 2 in the first, and then 3, 4, 5, 6, so we got 7, 8, 9, 10. So far we're up to 10 electrons, but we got 7 more to put in, and that third level can fit, remember, also another 8. But we only have 7 left to put, so we're going to put the first ones in at the compass positions, north, east, south, west, and then we've got 4, 5, 6, 7. All right? And that's our atomic structure for a chlorine atom. Okay? Flashing back to our notes here. Okay? And we can have a glance down here. So the next video that you're going to watch is going to kind of take us through, again, a recap of these arrangements of electrons here in these Bohr models that we see down below, and lead us into the process of bonding and how bonds form. All right? So just before we do that, I'll just quickly define here. A compound is any two different elements that are chemically bonded together, right? Chemically bonded. Sorry, my pen is a bit on the fritz here. Chemically bonded. Whereas a molecule is just any two elements, not necessarily different. They could be the same. Any two elements. Chemically bonded. Sorry, my pen is really glitchy. Chemically bonded. So how do we see that over here? Well, if we look up here, everything here could be a molecule, but only these lower ones are compounds. And the reason being is, to be a compound, you must contain different atoms. So see here, we got a nitrogen and an oxygen joined together. Here we got hydrogens and oxygens. So these are all molecules because they consist of 2 or more atoms joined together, right? 2 or more atoms joined together. And only these ones are compounds because the atoms that are joined together are different. Okay, so that's it, and you can watch the subsequent video as well, and then we'll do a recap on Monday's class.